Okay, here we are. Let me share my screen with 6.2. So we are going to be doing more work with exponents in this video. This is part 6.2. So let me zoom in so you can all read it well, and let's get after it. And 6.2 is more work with exponents. And in this lecture, we will learn how to use the power rule for exponents, as well as use exponent rules and definitions to simplify exponential expressions. Homework is problem set 6.2 on Math Lab, and the video will be linked as soon as I finish making it. So part 1, using the power rule. So what we're going to do is I'm going to just give you the textbook definition of it, and then we're going to do some examples. So if the initial definition confuses you, hang tight, we're going to work through it together. So the power rule and the power of a product or quotient rule for exponent goes as follows. If A and B are real numbers and M and N are integers, then A to the M to the N, so when we have a power to a powerception, we simply multiply our exponents. So that's going to equal A to the M times N. Next, we have power of a product. When we have a product, so we see A times B, product means multiplication. And when we have a product raised to a power, A times B to the M, we have to almost think of it as distributing the power to each of the bases, right? So AB to the M is equal to A to the M times B to the M. Power of a product rule there. And then finally, power of a quotient. That's A divided by B, a quotient, division. To the nth power is going to be A to the N divided by B to the N. B cannot equal 0. As usual, we can never divide by 0. That's old news. So that being said, let's go ahead and do some examples here. So number 1, we have x to the 5th to the 7th power. So this is straight up power rule right here. So we know A to the M to the N is going to equal A, but in this case we have an x, and we're going to multiply our exponents. So it's going to be x to the 5 times 7. We know that 5 times 7 is 35, so we're going to have x to the 35th. Next up, we have 5 to the negative 1 squared. Again, we're going to go ahead and multiply our exponents. So 5 to the negative 1 squared equals 5 to the negative 1 times 2, which is equal to 5 to the negative 2. And then it says use positive exponents to rewrite all answers. So we know this is going to be equal to 1 over 5 squared. And then we even know that 5 squared is 25. So we can rewrite this as 1/25. Next up, we have y to the negative 3 to the negative 4th power. And here, again, same thing we've been doing. Y to the negative 3 times negative 4 is equal to y to the negative 3 times negative 4, which is positive 12. So our answer is y to the 12th. So those ones were pretty straightforward. And now we're going to move forward with some trickier ones where we're using combinations of our different rules. So use the power rules to simplify the following. Use positive exponents to write all results. So I'm going to give us a little space to work through these problems. And we're going to start right off with number 1. We have 5x squared quantity cubed. So we need to remember that we need to distribute that cubed to each term. So this is going to be 5 cubed times x squared cubed, which is equal to 5 cubed is 125. X squared cubed, we know we're going to multiply. So we're going to have x to the 2 times 3. So this is going to equal 125 x to the 6th. Next up, we have 2/3 quantity cubed. So again, we know we're going to have to distribute our power. So 2/3 quantity cubed is going to equal 2 cubed over 3 cubed. We know that 2 cubed is 8 and 3 cubed is 27. So our final answer, 8/27. It's very common to want to look at this and think of it as like 2 times 3 over 3 times 3 or something like that. But you need to remember that 2 cubed is not 6. 2 cubed is 2 times 2, which is 4 times 2, which is 8. Same thing with 3 cubed. So just remembering how you know, exponents actually work. I know it's a lot to keep track of in your head, and I make this mistake all the time, so that's kind of why I'm saying it out loud, because then hopefully as I do these examples, I remember it as well. Next up, we have 3p to the 4th over q to the 5th quantity squared. So first thing we're going to do is take care of the quotient. So I'm going to rewrite this as 3p to the 4th quantity squared divided by q to the 5th quantity squared. And then from here, I have to do a little bit more work, right? So in my numerator, I know that 3p to the 4th quantity squared is going to become 3 squared times p to the 4th squared. And then my denominator is going to be q to the 5 times 2. 3 squared is 9. P to the 4th squared is going to be p to the 4 times 2, which is going to be p to the 8th. Over, I thought that was a 9. I should make my q with a little curly guy. Over q to the 5 times 2, which is 10. So final answer is going to be 9p to the 8th over q to the 10th. I know these problems seem intimidating, but you got to just kind of think about taking them nice and slow, one step at a time. Next up, we have 2 to the negative 3 over y quantity to the negative 2. So again, I'm going to take care of my outside exponent first. So I'm going to rewrite this as 2 to the negative 3 to the negative 2 over y to the negative 2. 2 to the negative 3 times to the negative 2 is going to be 2 to the negative 3 times negative 2. Negative 3 times negative 2 is positive 6. So I'm going to have 2 to the 6th over y to the negative 2. 2 to the 6th is equal to 64. And then again, I want to rewrite with positive exponents. So I'm going to bring my y up to the numerator, and I'm going to get 64y squared. Final answer there. Last but not least, number 5, we have a lot of multiplication going on here, but this one's actually not too bad at all. People tend to get intimidated by the quotient ones. Totally get it. They're kind of gross looking. And then these multiplication ones aren't as difficult, but I'm going to have x to the negative 5 to the 7th times y squared to the 7th times z to the negative 1 to the 7th. So I know I'm going to have to multiply my exponents out. Negative 5 times 7 is going to be negative 35. Y squared to the 7th is going to be y to the 14th. And z to the negative 1 to the 7th is going to be z to the negative 7. And then finally, I'm going to move my negative exponents to my denominator, and I'm going to get y to the 14th over x to the 35th, z to the 7th. Final answer there. Moving right along. So now we have part 2, using exponent rules and definitions to simplify. So here I have put a convenient table for you to fill out with a summary of rules for exponents. So I highly recommend printing out these notes and filling this in, or copying it down in your own personal notes that you're taking. But this is telling us that if a and b are real numbers and m and n are integers, then I want you to write the product rule, the zero exponent rule, quotient rule, negative exponent, power rule, power of product, and power of quotient. So this is going to be your cheat sheet for all the exponent rules. So I highly recommend filling that out. For example, it would look like this. Okay, product rule, I know that a to the m times a to the n is equal to a to the m plus n. Okay, so I want you to go back through your notes, go ahead and fill out the whole table. And meanwhile, we will do a few more examples and call it a day. So let me give you some more space on all of these really quickly. And let's do it. All right, number 1, we have 2x to the 0, y to the negative 3 to the negative 2 power. So first thing I'm going to do is take care of this negative 2 on the outside. And I'm going to have 2 to the negative 2 times x to the 0 to the negative 2 times y to the negative 3 to the negative 2. 2 to the negative 2, I'm going to leave. X to the 0 to the negative 2 is going to become x to the 0 when I multiply 0 and negative 2. So I'm going to have 2 to the negative 2 times anything to the 0 is 1. And then y to the negative 3 to the negative 2, I'm going to multiply those, and I'm going to get y to the 6th. And then final step, I want to rewrite with positive exponents. So I'm going to have y to the 6th in my numerator and 2 squared in my denominator. And I can rewrite that as y to the 6th over 4. Final answer there. Next up, we have x to the negative 5 over x to the negative 2 cubed to the negative 3. And if you haven't picked up in these problems, it's kind of easiest to start on the outside and then work in. So I take care of my outside exponent and then work inward. So again, I'm going to go ahead and do that right now. So I'm going to rewrite this as x to the negative 5 to the negative 3 over x to the negative 2 to the negative 3. Negative 5 times negative 3 is going to give me 15, x to the 15th over x to the 6th. And now I have division, and I'm going to use my product rule. So I know that this is going to equal x to the 15 minus 6, which is equal to x to the 9th for my final answer there. All right, number 3, we have 2/7 to the negative 2. And then again, I'm going to start on the outside. I'm going to have 2 to the negative 2 over 7 to the negative 2. I want to make my exponents positive, so I know I'm going to put my 7 in the numerator and my 2 in the denominator. And then I know that 7 squared is 49 and 2 squared is 4. So final answer, 49/4. And now D, final answer. I have 5 to the negative 2, x to the negative 3, y to the 11th over x squared, y to the negative 5th. So I'm going to do my little column strategy, right? So I'm going to think of my numbers first. 5 to the negative 2 is the only number I have. Then I'm going to think of my x's. So I have x to the negative 3 over x squared. And then I'm going to do my y's. So I have y to the 11th over y to the negative 5th. Okay, and so now I can think about this in terms of each variable, right? So let's do our x's first. So we have x to the negative 3 over x squared. I'm going to want to rewrite this as 1 over x squared times x cubed because I want to make that negative exponent positive. So I'm going to have 1 over x squared times x cubed is going to be x to the 2 plus 3, which is 1 over x to the 5th. And then in terms of my y's, I have y to the 11th over y to the negative 5. I want to make that negative exponent positive, so I'm going to have y to the 11th times y to the 5th, which is going to give me y to the positive 16th. So now when I go back to my original, I know that I have 5 to the negative 2, which I'm going to rewrite as 1 over 5 squared. And then I have times 1 over x to the 5th times y to the 16th, which is implied to be over 1. So now when I multiply my fraction, I can just go all the way across, and I'm going to get y to the 16th over 5 squared, which is 25, x to the 5th. Final answer there, y to the 16th over 25x to the 5th. That one was potentially the trickiest one we've done so far, but remember to keep your columns like numbers and then similar variables together. Do it one piece at a time, follow the exponent rules you know, and you will be good to go. And that's all I got for this video. Thank you for watching and enjoy your weekend.